Well, howdy there, Internet students. This is Mr. Hermanson again. Hey, we're going to do some equations, write some equations, and solve some problems where there's the variable on both sides. So here's what I'm going to do. You have 8 problems to do. I'll do 2 of them with you, and then you can finish them up. All right? So just a reminder of how to balance an equation when you have variables on both sides. Let me go ahead and remember whatever you do to one side you need to do to the other. So I'll just put a line there to remind me of that. All right. And then what we need to do is get rid of the variable from one side. So I can either get rid of this 2d or I can get rid of this negative d there. I think I'm going to get rid of the negative d by adding d. Remember, there's an invisible 1. So if we add negative 1d plus 1d, we're going to get 0 d's, which is 0. So that'll give me negative 17 on this side. And then on this side, whatever you do to one side, you have to do to the other. So I'm going to add the 1d over to there, and that makes 3d plus 9.7. Okay. Now I'm going to continue to balance this. I'm going to take away the 9.7 because remember I'm trying to figure out what d is equal to in the end. So I need 1d. So I'm going to take away 9.7 from 17, negative 17. And that equals I think that was wrong. No, that looks right. So negative 17 minus 9.7 is negative 26.7. I don't know where that 8 came from. But, and then on this side now we are just left with the 3d part. And then I just have to divide by 3. And negative 26.7 divided by 3 is negative 8.9. All right, so you can go ahead and do number 2 and number 3 here, just like that. Remember, if you have more than 2 terms on a side, which you do here, you need to combine like terms. Simplify that first. Okay, now what if you have words that represent a situation where you have equations on both sides? So here's one of those. It says, suppose the temperature in your town is 21 degrees Fahrenheit and is rising 1.5 degrees every hour. I can represent that by 21 plus 1.5 times x, where x is the number of hours it's rising. And then your friend lives far away, and in his town it's 28 degrees and it's falling 2 degrees every hour. So that expression for his town would be minus, because the temperature is falling, 2 degrees times however many hours. And we want to know in how many hours will the temperatures be equal. So I'm just going to put an equal there. Okay, and I'm going to solve it by balancing. I got to get rid of the x's from one side. I'm going to get rid of the negative 2x over here by adding 2x to both sides. So that gives me 21 plus 3.5x over here equals 28. Now I'm going to subtract 21. I'm trying to get it down to just x on this side. So that's 3.5x equals 7. Now I'm going to divide by 3.5 to get 1x. And that equals 7 divided by 3.5 is 2. All right? So the answer here is 2 hours. All right. Each of the rest of the problems on here you can set up the same way, where you'll have expressions on both sides with a variable and they will equal each other. just to get you started, I'll just give you the expressions for the next one, and then you can take it from there. But a town's population is 14,000, and it increases by 160 every year. So you can do 14,000 plus 160 times x, where x is the number of years in this case. You could use a y there too if you want it, wouldn't really matter. And a nearby town has a population of 24,000, but that population is decreasing, so we're going to put a minus there, by 200 every year. And we want to know when the two populations are equal, so we put an equal sign in between. And you're going to get rid of the variable from one side to start it, and then finish solving for x. All right, well, that's all I got for you today. Go ahead and finish those up, submit your answers on the Google form, and you'll be good to go.